Hello YouTube, and welcome to a audio restoration project of mine. This is an Optonica SM1616. It's a beautiful amplifier. It's the lower end of Optonica's 70s vintage line of amplifiers. These are its output hybrids. So yeah, this thing is about 40 years old, and it needs to be recapped, as can be noted by all these capacitors. Especially those caps are not looking good. So yeah, I have some new caps from Mauser, and I will be installing them. So stay tuned. This might interest you guys. I am using, well, sort of hot rodding this amp using VMA capacitors, these kind. And since the legs are very short on these, I'm soldering on some extension leads so I can put them in the amp. And this is how soldering those leads looks like. I'm using a stapler because I just needed a weight to keep the capacitor down. Then I just rest some solder on there. And put on. Doing this was suggested by some Audio Karma members. And they have had quite the success using capacitors in their amps. These are signal path caps. These are using the signal path, by the way, and replace some electrolytics. The same capacitance value. Okay, so now that that's done, I'll check the leads for electrical stability. They seem stable. So everything's really good. Excellent. Now comes the fun bit of bending these leads slightly, because they're being put into place where a capacitor, or electrolytic capacitor was, namely one of these. Now it requires me to bend the lead slightly. Okay, there you go. This cap is almost ready to be installed. All I need to do now is put some heat shrink on so that the capacitor does not short circuit with anything else. These are now much longer. That's a bit too long. Just shorten this a little. Okay, now let's shrink this. Okay, back from heat shrinking. Now this is the result. Now I need to do the other capacitor. Then I have the two signal path caps done. Okay, time to test the first section of the amp that I recapped. Now I'll be using my trusty cell phone. It's an audio source, and it's quickly the isolation transformer. See what happens. Light bulb. Huh. Well, that's interesting. I'll have to check that again. Okay, the plug was just not inserted correctly. That was the problem. Okay, so far so good. Now let's put everything. Well, so far so good anyways. Sounds quite awesome. Wow, that bass is just wow. Oh dear. That's interesting. The amplitude changed. Started going up, going down, going up, going down. Quite interesting. Sadly, the noise in the right channel is still there. It's a bit annoying, but I will be able to fix it sometime. I guess I need to replace the preamp transistors to fix that. I'll be doing that sometime. Probably not today, but some other time. Well, back to recapping. This might amuse you guys. These are 100 microfarad 35 volt caps from 40 years ago, and this is what the same cap looks like today. They are these are Panasonic FC capacitors, and these are Nichicon something there others. So yeah, time to recap. Okay, the next section has been recapped, which is still part of the preamp actually. It's the power supply section, and I'll see if it works now. Or rather, it still works. So, okay. So far, so good. Seems to be working. So it has the slight problem on one channel though. So yeah, I'd say so far so good. Okay, the next part of the amp has been recapped. As you can see now, these caps are new, those preamp caps are new, the phono caps are also new. I put some Nichicon FGs in there, and there's a Somic, or Vima FG, no, MKP, no, MKS2s. That's what these red guys are. So yeah, off to the amp section, I guess, which is this stuff. Also kind of funny that I replaced the Nichicons with Elnos and the Elnos with the Nichicons. I just thought that was funny. So let's see if it still works. No, still works. No explosions. It's good. Interesting thing, these fusible resistors here, they should be reading 150 ohms, and they are actually reading 150 ohms, which is quite unusual actually, because they usually drift out of tolerance insanely, so yeah. I still replace them with metal films though, because, hey, I'm already recapping, so I might as well replace these too. Well, I found something interesting. C501 and C502 are dissimilar, and on the schematic, you can probably tell, these are these are the two capacitors I'm talking about. They should be 3.3 microfarads, 50 volts, but the C502 is a reverse installed 10 microfarad, which is fascinating, to be honest. I fully expect that someone worked on the amp and put that thing in. Kind of curious to see what happens, or what's going to happen. They change these two capacitors. These should be 3.3, but one is 10 microfarad. One's an Auna, one's an Nichicon, and I replaced them with VMAs. So let's see if that fixes the fun noise problem in the right channel, because the 10 microfarad was in the right channel, and its polarity was reversed. Okay. Nope, still there. Sounds more balanced now, though. I'd say that works. It's interesting though. Oh well. Back to recapping. Well, I'm gonna have to remove the front panel now, because I need to get at a capacitor which is under this metal tab. The only way to get at it is removing this board, or using some oddly shaped soldering irons. And neither of these two will work for that. Oh, this knob is being annoying, so I will use 2 spoons to get it off. I've already created this adapter plate. I still not damage the fixed plate. Okay, the stubborn knob is off. Now that without destroying the faceplate. All it took was 2 spoons and a piece of cardboard. And a knife to cut the piece of cardboard. The adhesive tape holding the power meters, aka VU meters, in place has well, disappeared. So it's time to replace it. Scraping off the excess. Make way for the new stuff. Okay, that's completely there. Okay, now time to use some alcohol. Wipe the rest off. Considering it dissolves in the way using the alcohol. It's actually ethanol. The actual alcohol I'm using. The alcohol, ethanol, is the alcohol you actually drink when you drink, say, beer or schnapps or some other things. But it's quite effective at getting rid of foam, interestingly enough. Okay, about as clean as I can get it. So, time to apply the new tape. Just put this away. Scissors. I need to. Okay. There. Back in place. Time to give it another go. I finished recapping the power amp section. And I am about to power the amp up again. Ooh. Well, the left channel works. That's at least something. Another test run of the amp. Fixed a solder joint in one of the resistors I replaced. It was causing problems, I think. And we'll see if the amp works now. I'm also measuring DC offset using the clamp meter and a 4.6 ohm resistor. Okay. The isolation transformer's on. So far so good. Works again now. Okay, now to the DC offset. Wow, 31 millivolts. Impressive. Okay, now let's check the other DC offset. That might be because it's plugged in or something. So, let's see. Also 30 millivolts. That's a bit worse than last time I checked. What was that, 24? Well, at least the amp works again now. That's good. So I can continue recapping. Here you can see an example of some bodging, or flying wiring, or whatever you want to call it. Essentially, what has happened is, sorry about that, there is a resistor here, it should be 1K, and a capacitor being 3.3 microfarads. And in the schematic, they're both put together, and on the circuit board, they are put together literally. And apparently it was meant, the amp was meant to not have a capacitor in there. Apparently they added that after the fact. So yeah, I'm going to do that too, and replace them with MKVs, and this is what I came up with to replace them with. Much nicer. The resistors are also 1K precision metal film, not from Vichy this time, but from Zion or something. If I remember, I'll put a annotation to what the resistor manufacturer is. Funny thing is, the original resistor here is actually closer to 1K than the precision metal film. And this is a carbon film, so yay. So, back to recapping. Okay, next test run. And hopefully the last test run. Because now every capacitor in here has been replaced except the main filter cap. Which is a bit hard to replace since it's a Nichicon dual C, or yeah, dual C, aka dual capacitor. It's essentially two capacitors in one, and it's a bit hard to replace those because I need to restuff them. I currently do not feel inclined to do so. Okay. Isolation transformers on. Almost no kick from the meters. Offset is at 3.3 still. Or so around 30 millivolts. Oh wow, the amount of hum here is quite strong. The hum was just from the phono preamp. Sounds quite amazing. I'd say the recap was a success. All I need to do now is fix the noise issue in the right channel, and I'll be done. And from what I can tell, that issue is coming from the preamp transistors, so I have to change those. But that's for a different time. So, I'll put the amp back together now. Well, it's time for a proper listen with a good pair of headphones, not cheapo test headphones, and a cell phone as a sound source. So I'm putting the amp back together. One thing I haven't done is calibrate the meters yet, but that's something I'll do another day. Probably the same day I'll change the transistors. The preamp, for which I first of all need to match transistors in order to do that, because it's a differential pair input, and it's made of discrete components, unlike the differential pair for the power amp, which is a dual transistor thing, which is hard to get. Well, it's actually impossible to get unless you get a new old stock one, which I just might need to do on this amp, not sure. I'm pretty sure it's the preamp that's creating the noise issues. So, time to put the lid on the amp. Didn't need to do much cosmetic restoring, but still. I'll continue recording once I'm done putting the lid on. Or actually, thanks for watching, guys, and see you in part 2, where I replace the preamp transistors in the hopes of tracking down the pink noise type issue inside this amp, which is actually a bit of a problem. I thought it was going to be a capacitor or a resistor that's creating the noise, but nope. It seems to be the preamp transistors acting up. Well, that's at least my guess. I already have the transistors here for Mauser Electronics, but don't have the time to sort through each of them and get a matched pair for each of the inputs. Because if you change the transistors in one channel, you need to change them in the other channel as well, else you will have balance issues again. This amp has more DC offset, is annoying me, but it can't be changed. DC offset is set, well, it cannot be set properly. It can only be, well, it can't even be adjusted unless you go into the output hybrids and change a few resistor values or something in there, then maybe. But since I don't feel like rebuilding an IC right now, I'm just going to keep it at this. And ta-da, the amp is back together now. Let's see how it sounds. I will tell you guys how it sounds in the next video, which will come out sometime. So, thanks for watching, guys, and see you next amp restoration, or the next part of this amp restoration. I have this this amp's big brother as well, which is the SM1616, and it's also waiting restoration, and I also have the parts here already. I just need to get this one completely up and running again before I start the 3636 amp, which actually probably sounds better than this one, but now this one probably sounds better than the 3636 in its almost 40-year-old state. So, thanks for watching, guys, and thanks for watching. Bye-bye.